All right, welcome back to Computer Vision. This is going to be our last lecture or lesson or whatever this is on frequency analysis, and I bet you're happy about that because it's kind of off in the ozone of mathematics, and it's going to be hard to pull it back to the work that we'll be doing in terms of manipulating the images, but it's important. And in fact, today we'll finally get to the coup de grace, pièce de résistance. My French is terrible. What I really wanted to get to was the notion of how frequency explains the notion of aliasing. So if you remember, we've been talking about Fourier basis sets where we decompose things in terms of sinusoidal bases, and this is the picture we've been using to represent that. And then we talked about the relationship between convolution in the spatial domain giving you multiplication in the frequency domain. And we showed it with the math here. We said that if g was the convolution of some functions f and h, that we could derive that convolution in the spatial domain was multiplication in the frequency domain, and that was shown like this. And by the way, then this is really important for today, that multiplication in the spatial domain is convolution in the frequency domain. And you might ask, when do we ever multiply functions together?
When do we ever multiply functions together?
Today. It'll be some very special functions, but we'll do that today. We also showed some Fourier pairs. We talked about how the Fourier of a Gaussian is another Gaussian. We talked about an impulse is straight. We spoke about the box filter giving you this sinc thing that explained ringing and that like.